They said that pastel colors are like supposed to be a calming color to the brain. So I'm using pink because it's supposed to be calming. So we're going to start talking about equations today. So equations is really a lot of the stuff you've been doing, but now we're adding an equal sign. And you've probably seen me use an equal sign before. Like if I gave you an expression like x plus 2 and I say x equals 5. So over here, this is what's considered an equation. Equation is anything with an equal sign. And of course, if this was a test problem, you would say, okay, this means that 5 plus 2, oh, that's 7. But we're going to focus more on this part right here. So let's start with like a simple equation. You might not even think of this as an equation. But like if I had something like 2 equals 2. Because 2 equals itself, right? That's kind of almost looks like it's too simple to be true. 2 equals 2. But I can't do something like this. I can't just say 2 equals 2 plus 2. Because that's false. That 2 plus 2 is 4, and 2 does not equal 4. 2 equals 2. But something I can do is if I add 2 to this side, I can also add 2 to that side. Now this is a true statement again. 2 plus 2 is 4 equals 2 plus 2, which is also 4. So yeah, that works. 4 equals 4. So we're introducing that equal sign. The equal sign is an equation. Sign to solve for things that are not known. We're going to solve for unknown variables. So let me open the notes and I'll show you what I mean. We're going to start on the first page of the notes. So it gives you the definition of an equation. A mathematical sentence that uses an equal sign to indicate the left side of the equal sign has the same value to the right side of the equal sign. Well, that's just saying that whenever you have an equal sign, the left side has to equal the right side, always. And so we're going to look at these things called one-step equations. Like here at the very bottom here we have 2 plus x equals 6. And we want to know, well, what is x? If you know it, don't shout it out loud. But, like, what is x? Or x minus 7 equals 4. Well, what is the value for x over here? But we have to keep that equation balanced. Just like I was showing you, 2 cannot equal 4, and 4 cannot equal 2. I have that equal sign is very important. I had to find a way to keep the equation balanced. That's why they're going to have a little seesaw to demonstrate that. So let me help you fill these boxes up here. So inverse operations. In order to solve equations like the one to the bottom, we need to know the inverse operations. And I'm going to see if you guys can guess. For example, addition. The opposite of addition is subtraction. Yep. Can anybody guess the opposite of subtraction? Yeah, addition. There we go. What about the opposite of multiplication? Division, yeah. What about the opposite of division? Multiplication, exactly. And then the next box there says to solve a one-step equation, isolate the variable. And remember, a variable things like x, a, b, or c, or any of those alphabet letters. Isolate the variable with the inverse or opposite operation. So inverse operation, that's all this stuff up here. So like the inverse of addition is subtraction, and the inverse of multiplication is division. And that goes the other way too. Division inverse is multiplication, opposite of subtraction is addition. So let me give you guys some examples, and then I'll ask you guys if that makes sense or not. I'm going to give myself a little bit of room, but I'm going to do this first example right here. Just going to go So I'm going to rewrite that first problem like we're used to seeing it. Oh, thank you, sorry. So, what did it say? It said 2 plus x. 2 plus x equals 6. So something that some people find helpful is that if they draw a line down here with the equal sign is, that helps them remember which side of the equal sign everything is on. So the whole point of this equation is that we're trying to figure out, well, what is x? And you might have done some of this stuff in math lab, like 2 plus what equals 6? Can you guys do that in your head? 4, yeah. 2 plus 4 equals 6. But I want you guys to try something a little new. Instead of doing this in your head, I want you guys to show how to do that algebraically. So this is called pre-algebra, and this is kind of like the algebra part of pre-algebra. So 2 plus x equals 6. So here's my equal sign. I have to keep my equal sign balanced, which means if I do something to the left side, I have to do the same thing to the right side. So if 2 is added to x, what's the opposite of addition? Subtraction. So what I'm going to do is I'm going to subtract 2 from both sides of this equation. So 2 minus 2 is what? 0. Yeah, so that all gets canceled out. 6 minus 2 is what? 4. Yeah, 6 minus 2 is 4. So when I bring that down, now it's 0 plus x. Well, 0 plus x, that's just x. And then I have 4 on the right side. So x equals 4. And that's that first problem solved. Does that make sense? Let's do another one. Let's do the next one. X minus 7 equals 4. Can I move it up? Maybe? Okay. X minus 7 equals 4? Yeah. Okay. Just going to draw a line down here. Okay, so x is being subtracted by 7, but we want to isolate x. We want to get x by itself, is the way my teachers used to say. We want to get x by itself. And so somehow we need to move the 7 over here. So what is the opposite of subtraction? Addition, yeah. So I'm going to add the 7 to both sides. What that does is that negative 7 plus 7, that's 0. So those just are basically canceled out. And so on the left side, all I have left is x, and I'll put my equal sign right there. Now I have to figure out what is 4 plus 7. 11, yeah. So x equals 11. And if you're not sure if you did everything right, well, just plug this value, do I have pink? No. Plug this value back up here. So 11 minus 7 equals 4. Yeah, that works. Okay, you have any questions before I do the multiplication and division ones? Okay. Let's see here. I'm trying to figure out how far I'm going to go today. I think we'll stop after the first 2 pages. Okay. So next one is 3x. I'll just write both of them on the same page. 3x equals 12. 3 times x equals 12. And x divided by 3 equals 12. Okay, so they both equal 12. X divided by 3 equals 12. Okay, so 2 different problems. Let's draw a line. Okay. So this one says 3 times x equals 12, and we want to isolate x. We want to figure out what x is. So this says 3 times x. What's the opposite of multiplication? Division. So, draw my line, so remember that's what the equal sign is. So, instead of adding or subtracting, I'm going to divide both sides by 3. So I'm dividing both sides by 3. What is 3 divided by 3? 1. So I'm left with 1 times x. But 1 times x, we already know that that can just be expressed as x. So I'm just going to write x. Okay, and what's 12 divided by 3? 4. So x equals 4. And if I'm not sure about that, I can just go back to the original equation. 3 times x, or 3 times 4, well, that's 12. So yeah, that works. So then there's x divided by 3 equals 12. Okay, this one is division. I want to isolate x. So what's the opposite of division? Multiplication. So now instead of dividing, I'm going to multiply both sides by 3. Whatever I do to one side, I have to do to the other side of the equal sign. So this is 3 times x divided by 3, and this is 12 times 3. So what happens over here, I'm gonna make an extra step just so you guys can see this. This would become 3x divided by 3 equals 12 times 3. So when I have something on the bottom and top of a fraction sign or a division sign, those two things cancel. It becomes 1. So those cancel. 12, and what's 12 times 3? 36. So this one, x equals 36. Say it again. You don't get the division part? So, like if I have a little sidebar here. If I have 3 divided by 3, what would that be? Yeah, anything divided by itself is 1. So if I add an x up here, well, 3 divided by 3 is still 1, but now I have that x there. So 1x, that's the same as just saying x. It's the same thing. That make sense? Okay. Any other questions? If I move too fast, let me know. Like this is the first time I've ever taught this, and I've been using equations so long, so if I go too fast or something's confusing, please let me know. Okay, I've tutored this a lot, but I've never taught this as a brand new concept. Okay, let's see if I'm going to go to the second page, and we're going to do these examples together, and then I'll let you guys try some on your own. There is some other examples in these notes, but we're not going to go over all of these. Actually, no, these are two-step equations. Hang on, what page am I on? Yeah, there are some other examples, but I'm just going to focus on these 4, and then I'll let you guys try some on your own. Okay, x minus 7 equals 15. Let me see if I can zoom in a little bit. There we go. So x minus 7 equals 15. So we want to isolate x. So what do I need to do to isolate x? Get x by itself. I need to add, right? Exactly. Good job. What do I add to both sides? Yep. So I add 7 to the left side, but that means I have to add 7 to the right side. So negative 7 plus 7, that's just 0. So I'm just left with x now. So 15 plus 7, does anybody know? 22, yep, 22. And then we're done. What about the next one? X plus 10 equals 57. How can I isolate x? How can I get x by itself? Subtract, yeah. So x plus 10, that means I have to subtract. And what am I subtracting? 10. So subtract 10 from both sides. Yep, 10 minus 10 is 0, so x is on that side, so all I'm left with on 57 minus 10 is 47, like you guys said. Good job. Questions about those two before I go down to the bottom? The bottom two. Okay, so 8y equals 72. Yeah, I gotta divide by 8 because this is 8 times y, so I have to divide 8 on both sides. Did you say y? Because, no, I'm kidding. Sorry. I was trying to start a joke, but then it wasn't that funny, so. Okay, so I'm left with y on that side, and then right side 72 divided by 8 is what? 9, yes. Okay, last one. Oh, you don't get this one? Okay, that's fine. So we're trying to isolate k. We want to get k by itself. Okay, so k is being divided by 4. So what's the opposite of division? Right, so I have to multiply 4 on both sides. So this is like saying 4 divided by 4, which is just 1. So when I do that, that cancels the 4, and I'm left with just k. Does that make sense? It does. You can do either side first, but I'm just showing you how that cancels out. So then 4 times 13 is what? 52? I think that's right, yep. Guys, any questions about those? Okay. That's okay, I'm not going to take it off the screen, don't worry. I have 12 questions for you, or 12 problems. I just want you guys to try it out. It's just, the answers are on the back, so you guys can check. It doesn't show you guys the solutions, but it shows you guys the answers. So I want you guys to try this out, and just use the rest of the class to work on them. You guys got a lot of classes left, so it's really no pressure. Oh, I'm sorry, there's 10 questions. I thought it was 12. There's only 10.